Here we are with the short Unit 5 overview. So here's a quick look in the timeline for the year. You can see the patterns that are reoccurring here. And then a little bit over here, I'll be able to see it bigger on the next slide. So I'm going to first, though, show you the hook. All right, day one hook. First thing, have a student go out in the hallway, call a student in the room, all prearranged. They answer it, turn on speaker, and the first student asks, "How are you hearing me?" That is our driving question, our essential question for this unit. How are you hearing me? All right, so this is that look, Unit 5, Waves and Technology, with doing most of the good stuff of a cell phone conversation or send a text. It's about 7 weeks, the performance expectations, wave equation, digital transmission and storage, evaluating published materials on electromagnetic radiation, and then understanding technology that uses wave behavior. You can see the assessment opportunities, having students use the big ideas of science to explain phenomena and solve problems. That's what's here. All right, so again, just like so many other units, we took a break with Unit 4, but system analysis is back. Just want to point out that it is exposure, real simple, like 2 might be phone does its thing. It is going to take them weeks to put this all together and refine it, but this is exposure. Also on day 1, they do most of the good stuff of the unit. They are sending information like a number 4. They might send 4 pulses down a slinky. So nothing builds success like success, but there's a lot of work to do before they do most of what really happens in a cell phone call. Just want to put a shout out even in the short video that the reading, you could drill this and kill this, but that is not the intention. Exposure. They read it and they're going to go back and reread it a few weeks later and really get everything. So just a light touch, they read it, see what they get, what strategies they use, and move on. Then we do that intro experiment, really up their game. They have 2 research questions, they get 2 data tables, 2 graphs, but they put it together into a single wave equation. So the lab reports are increasing in rigor. Then we're off to doing a lot of that performance expectation about technology using wave behavior. They get background on a patient with a knee injury, they get the raw data, and then they have to code spreadsheets to make a sonogram, a sound image. And so you could tell this one on the right, not having the gray here, most likely means it's patella tendon and that kneecaps is gone, unfortunately. All right, so they're using the big ideas of science to explain phenomena, how ultrasound works. Then we have an activity on do cell phones cause cancer around that, evaluating published materials. We're in Unit 3 and 4, we're building up to this practice, exposure, and hopefully now we're at mastery. Then the next one is a stations day or 2. Excellent day, guide on the side. It's really great. It gets at a lot of the wave behavior and some of the evidence statements and those performance expectations. And then that leaves us really with the final engineering challenge. They know that they are doing most of the good stuff of cell from early on, but now we give them the technical details. Here is that rereading where they make a lot more sense of it, but here's a bigger image. They have to send a signal down 150 feet and then around a blind corner using AM, FM, light, sound, and several other things that you'll see in the portfolio that launches it. When they get to the programming the encoder decoder, this is definitely a step up. And we went and talked to computer scientists and programmers. What do you do when a software gets more complicated? They storyboard it. Students also did that with the medical ultrasound imager, but this is the first time I'm showing it in the videos. And so some students, I want to be clear that there is 3 levels of support, customized videos for all of it, but we want to move them away from just watching a video and copying what is done. So this is that attempt. And some students, this is enough help that when you go through this and develop it, that they have enough now. However, if that is not enough, which it oftentimes is not enough, you do have all of those videos. So I'll just jump back and scroll up to show that. So multiple levels of support, customized video tutorials for all of it. But it is kind of cool to see. So they ultimately code this, 3-letter word. First thing it does is it breaks it into its individual letters. And then you, as a user, have to put in which letter you're deciding to encode. And everything changes, and you get both an amplitude and a frequency modulated wave that they then need to actually put into light or sound. So all good stuff. Then wanted to just show that the engineering portfolio, no surprise, the problem statement, the early unit used the big ideas of science to explain phenomena, and then the end of unit, advanced physics of a cell phone communication, good stuff. And then in the engineering project, they use the big ideas of science to solve problems. And so they really make a transmission protocol, think 4G, 5G, 6G. And then of course they have their encoder and decoder for that matter. That all wraps up the end of the unit where they do most of the good stuff and answer the question, how are we hearing someone through a cell phone? And then want to point out that there's an awesome extension. It could be a whole class extension, or if some students are ready to move on and you need more time with students to finish up the portfolio, there is a pretty self-guided activity where they make $3 electric guitars, think plastic jugs and fishing line, but they really work. And in unit 6, we'll turn these electric. All right, with that, I'm going to wrap up.